Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. It's Aaron, and here in the United States, we are well into fall. The end of the year is in sight, and before we know it, the holidays will be here. We certainly hope everyone out there takes some time for family and friends. And of course, if you are traveling, make sure you stock up on Cloudcast to listen to. Get caught up on all of those back episodes you haven't listened to and give you something to pass the time in between destinations. As for me, I've been somewhat absent here recently. I started a new job a few weeks ago and I've been getting adjusted and settled in, but things should be returning back to normal by the end of the year or so. With that out of the way, let's move on to our interview. This week, our topic is network observability, and we're joined by Rosalind Whitley and Ethan Smith, and we dig into this conversation right after the break.
Hey there. As a listener of the Cloudcast, you're probably also interested in data, especially about the ways in which it continues to shape our world. So you need to check out Data Citizens Dialogue, a forward-thinking show brought to you by the folks over at Calibra, the leader in data intelligence. You'll hear firsthand from industry titans, innovators, and executives from some of the world's largest companies as they dive into the hottest topics in data. You'll get insights to everything from popular staples such as AI governance and data sharing, down to more nuanced questions like how do we ensure data readability at a global scale. My favorite episode so far is called How Data-Driven Care Changed the Healthcare Game. My family is part of the sandwich generation, so we're caring for younger and older family at the same time, and the insights in this show were really, really valuable to me. While data may be shaping our world, Data Citizens Dialogue is shaping the conversation. Follow Data Citizens Dialogue on Apple, Spotify, YouTube, or wherever you get your podcasts.
Welcome back to the Cloudcast. I'm your host, Brian Gracely, and excited to get into today. As many of you know, if you've listened for a while, I have a long-time background in networking. It's something that, while I don't do it every day anymore, is still kind of near and dear to my heart. It was sort of the foundation of how I got into technology, and it's always interesting to me to have an opportunity to go dig into how has it evolved, how has the technology evolved, how do people build and operate large-scale networks, but then more importantly, how has it evolved as our environments have changed, right? We no longer just work in one central office. We no longer just work in the data center. Our applications are really distributed. So really excited today to get a chance to dig into what does it look like as we're managing the network, security, and all the things around that in some of the very, very mainstream SaaS applications that we use every day. So really excited today to have two guests with me. The first is Rosalind Whitley, who is Director of Product at Kentic, and also Ethan Smith, who is Staff SRE at one of the very large networking and security companies that many, many of you use. And for fun legal reasons that none of us want to deal with, we're going to kind of avoid names on that. But Rosalind and Ethan, great to have you with you. Great to have you. Welcome to the show.
Thanks, Brian.
Thanks for having us. I did not know that you were a networking person. By the way, I kind of want to hear about that.
Yeah, well, I was Cisco CCIE way back in the day, back in the 90s and early 2000s. So kind of old school networking stuff. So, well, Rosalind, why don't we start with you? And I want to kind of get both of your backgrounds and a little bit of where you focus today, so that we can dive into our conversation. But why don't you go ahead and give us a little bit of your background, as well as what your focus is over at Kentic these days.
Yeah, absolutely. My background, I was like a childhood Linux nerd, and I have a degree in information systems, databases, and internet technologies, but I don't do that anymore. I was a sysadmin at the University of New Mexico for several years, and then I went to Puppet as a solutions engineer, and I worked at several kind of DevOps and hosting companies since then. But I'm actually like over in the dark side of marketing now. So I work in product, like kind of technical product marketing at Kentic, which is a network observability company. So I've sort of had an interesting career that went from being on call a lot and learning that sucked, and then learning how to talk about the same things and feel that same pain without actually feeling it.
Yeah, Very cool. Very, very cool. And speaking of that, Ethan, I want you to give us a little bit of background. And folks, we may get a really fun live situation. Ethan is actually on call as we're recording this. So at some point he may either have to jump off or he may do an amazing thing and just troubleshoot stuff while we're doing the podcast.
No.
So Ethan, give us a little bit of your background as well as what you're focused on these days.
So yeah, unfortunately it is my on-call week, but I'm still happy to be here and talk about networking. I've been in networking in one form or another for at least the last 15 years. Early career, I started out kind of the traditional data center and stuff like that. I did some work at a call center, SIP administration, routing, phone trees, all that fun stuff. I've done enterprise wireless deployments and distribution centers. I've done data center build outs. Today, I'm mainly focused in public cloud. I have worked public cloud and hybrid deployments before with on-prem data centers. I've worked for some big companies. But today it's pretty much all public cloud, all AWS, GCP, Azure, that type of stuff.
Yeah, very good. Very, very cool. Well, listen, Rosalind, I want to start with you because I know that you get a chance to work with a lot of large SaaS companies, Ethan's company included. Networking has become a very complex thing, and especially now that we're doing stuff in the public cloud, we have to think about everything from the standard stuff like routing and addressing and bandwidth, but we also have to think about costs. We have to think about different ways of doing security. Can you walk us through as you're talking to a lot of these operators, these service providers, like what are the breadth of things they're having to consider that we may not necessarily think of as like standard networking stuff or standard security stuff? What's the bigger sort of Venn diagram that they're having to be challenged with these days?
That's a really good question. And I also want to just put a little asterisk. When you say they, I think it's a really big question of who you're actually talking about. And I think we may talk about that a little bit later in the podcast, but who are these people who are managing workloads in the cloud? I think that's something that's been evolving over time. And that in itself is quite interesting. But I think that so you've got your sort of what's happening at layer 3 and 4, and in the cloud, a lot of that it has been commoditized and abstracted, just like so many other things have been abstracted and commoditized in the cloud, right? So you could be managing compute like EC2 style, and then kind of networking servers between those in a way that is not totally dissimilar to what you would have been doing in the data center, or what you could also do in the data center. But you could also be going all the way to like maybe, and I think actually a lot of what we're talking about here is at large companies, there are generally a lot of application teams who are building and deploying software. And there has been this sort of idea that those folks should maintain and keep reliable their own services. I think that idea was really popular, especially like really kind of like about 5 years ago, that idea was really popular. And I think one of the things that we found out from the popularity of that idea is that it doesn't always work very well, right? So we have this, it's hard. So we have now this sort of class of engineers who are really focused on keeping those services reliable once they've been developed and deployed and are part of the part of the software life cycle of the company. So I think with that, like what the gamut, to your point, Brian, of things that people have to deal with from serverless functions to clusters and Cube to your just regular EC2 instances to storage, and maybe you have some kind of data science-y workloads that are happening. Maybe they're happening in the same environment where your application is serving requests. Maybe that's happening somewhere else. But all of that kind of ecosystem of a variety of different types of infrastructure being put together to serve different business purposes, like those are all part of a thing that like a site reliability engineer or an infrastructure engineer, or maybe we call them a cloud engineer, might be dealing with at any given time. And what I think is interesting about that is that none of us can possibly have expertise in all of those things at the same time, right? Like we may have some experience working with one thing a few years ago, or I used to work on databases, like relational, non-relational databases. I used to be the database person, and when we had an issue that we knew was looking like that, like I would be the person to dig into it. But could I go in there today and like troubleshoot? Maybe I could if it was like an Oracle thing, but could I go in and troubleshoot someone else's application that's having some kind of database error? Like probably not.
Yeah.
I'm not sure if I answered your question, but
no, I think it's I think it's good, because I think what you really highlighted was we go through these trends in technology, and like you said, if you went back 5 or 6 years ago or 7 or 8 years ago, you used to hear Werner Vogels and others who would say, "Yeah, look, the world is moving to you build it, you operate it, you run it."
Yeah.
And while that sounded really cool because it felt like, okay, I'm breaking free from kind of the old structures, there was lots of people who were like, I don't know if I want to maintain it, or I don't know if I have like you said, I don't know if I have the breadth of skills to do that, because when I look out of the trees in my backyard, there aren't a bunch of 10x engineers hanging, kind of growing on those trees. And so it does become this evolution of like, well, how will we get there, right? Like the concept makes sense, but how will we get there? And I think that sort of encapsulates what I'm hoping we dive into today, which is, how has SRE evolved? What have the tools evolved to? And kind of how the teams have evolved too. So I'm gonna kind of transition that to you, Ethan. Within even your organization, there's usually a lot of teams that are doing things, right? Whether it's like Rosalind mentioned, you've got application teams doing things, you've got infrastructure and operations, you've got security. Like, how are you guys, especially in sort of a modern world, how are you able to collaborate across those teams? And then what are some of the hurdles that, because not everybody's a 10x engineer who does everything, like what are some of those hurdles that you guys have to deal with, just because of the nature of multiple teams and things like that?
Yeah, it's really interesting to think about, because if you think about a traditional data center, if you're an app developer, you build your app, and then you're going to go talk to a server admin and say, where can I deploy this? And then they might talk to a network engineer and say, well, do we have the bandwidth? Is it routable? Is the firewall functional? Is it going to allow it? So you kind of are forced to have this degree of collaboration in a traditional data center. And it's such a good point that in a cloud, if you're the app developer, you can say, well, I know how to run Terraform. I'll just deploy my own servers and I'll, deploy an app gateway and we'll get out to the internet and everything is great. But you lack a lot of context there. You might scale this out and then start hitting issues with your NAT gateway. You might hit port allocation problems, and then you don't understand what's happening. You just know you can't reach the internet anymore. So it's a really good question as far as how do you collaborate in the cloud in this kind of new environment. And I think the answer is really remember your infrastructure teams. They can help you. They can help save a lot of headaches in the future, especially when you start to scale. It's so easy to deploy small stuff in the cloud and have it work flawlessly. But when you're dealing with, thousands of connections at a time or millions of connections at a time, you start hitting problems that, just your average full stack engineer isn't going to encounter. That you really need these kind of infrastructure teams to step in and say, okay, well, I've seen this before. This is what's happening, and here's how we're going to fix it.
Right. Yeah, it's just remember that the shallow end of the pool and the deep end of the pool are two very, very different things.
They are very different.
I want to follow up on that a little bit. The role of SRE and network engineer obviously have evolved. You've got you come with a lot of background, but as you're helping teams, you're trying to find the right mix of how do I help teams, how do I keep the skills. Like how do you start to think about kind of blending together the technology needs, right? So network performance, the security, but also then start to think about the business level thing. So for example, like how much does this service cost? How can we be more efficient in this that maybe you didn't have to think about in more traditional days, or maybe when you weren't having to think about delivering a service that you were trying to drive a profit for.
Yeah, it's kind of interesting to think about, because I'll kind of do the comparison again with an on-prem data center. Your expenditures are upfront, right? You buy a core switch and you buy distribution switches and you buy firewalls, and they're all very expensive. It's a high, it's a high barrier to entry. But then once it's deployed, you can move all the traffic around you want, and it's basically free because you're not paying again. You have support contracts and data center costs and stuff like that, but it's really just that upfront cost. With the cloud, it's the exact opposite. It's really cheap to get started, and as long as you're pushing small amounts of traffic, it's still cheap. But as you scale, you have to start thinking, using Amazon as an example. If you're talking VPC to VPC and you're using a transit gateway, well, it's 2 cents to get on the transit gateway. If you're crossing a region, it's 2 cents to cross the region. The response costs 2 cents to get on the transit gateway, and it's 2 cents to cross the region. So you're 4 cents a gig. And if you're only doing, a couple gigs a day, it's not a big deal. If suddenly you're doing 1,000 gigs a day or 10,000 gigs a day, it's really expensive really quickly. And it's those types of costs that you really need to think about when you're designing, as far as, do I need these in separate regions? Do I need them on a transit gateway? Do I need to inspect? Do I trust the traffic or not? Because it can get really expensive and it'll sneak up on you.
Yeah. And it may not be a bill that you immediately see. It may end up going to the finance department. It may go to a different group. And
exactly. Yeah. And, just VPC to VPC is one example, but you see it really commonly with NAT gateways and Amazon. Developers will just say, they love automation. Everybody loves automation. You love tearing down servers and building them back up, but you're downloading images when you do that, and you're downloading packages, and you're downloading all this stuff. So if you're doing it hundreds of times a day, you're downloading the same data over and over and over again, and that can get really expensive as well.
Right. Yeah. No, I know for anybody that knows or follows Corey Quinn, who likes to cover a lot of AWS stuff, NAT gateways are always his thing. That are they're sort of a pecking order of things that are the most expensive things in the world. It's sort of like a block of unobtainium, NAT gateways, and a rocket trip to the moon or something like that. So yeah.
And Rosalind, we hear that from our
go ahead.
We hear that from our customers a lot. Like, oh, we found all of these costs that were essentially associated with CI. And I think like people think of CI as like this very cheap, lightweight thing that people can do. And I think that some of those costs, even in like a cost explorer like Cloudability or something, I don't know that all of those costs are always surfaced, right? Or it's not obvious that they're coming from a process like CI that seems so innocuous. So yeah, we see that a lot.
Yeah, Amazon's really good about telling you how much your NAT gateway costs, but not why.
Why?
Right. Well, and it's, the difference between a line item on your bill and architectural understanding of it can be two very, very different things. I know you went through, we had a chance to talk before the show. You were talking about sort of an interesting example that you walked through in terms of NAT gateway costs and S3 gateway costs and some of the difference between them and some of the functionality. Can you kind of walk through that for folks, just as best as you can, without having a whiteboard, as to how you found the cost differences and just how you were able to save yourself a bunch of money?
Yeah, and this has been the case for several companies I've worked for, and it kind of goes back to, you have a developer or somebody in your infrastructure team that's like, well, I'll just deploy this service, I'll send stuff out to S3, everything's great, and it works. But there are these things called VPC endpoints in Amazon, and basically what they do is they keep traffic off of your NAT gateway as long as you're calling the Amazon services that matches that VPC endpoint, and it's the same region. So in the case of S3, they're a slightly different endpoint type. They're a gateway endpoint, and they're basically free to deploy. So you can either use these endpoints and send data to S3 and get it back, and it's all really cheap or free, or you go out the NAT gateway and it's 4.5 cents. And that's 4.5 cents per gig processed. So it's, you get billed pretty heavily on that, especially if you're using S3 as any kind of mass storage repository, if you're pulling data and evaluating it or whatever.
Right. Yeah. And that's, I think, as I talk to a lot of people, that's often one of those areas where, like you said, as you move from the data center to the cloud, and you're so used to doing CapEx style things where you might be thinking about what is a cost per gig cost for a storage array or ports on a switch. Like, you don't think about the transactional cost. You don't think about some of those things. Rosalind, Ethan talked a little bit about, having to do a certain amount of things as planning ahead of time. I know within your platform, you guys are able to do some really interesting things from like sort of historical and network studies. Can you talk a little bit about how you're able to bring, kind of some insights before people go off and do some things that might become either costly or, open security holes or things like that?
Yeah, absolutely. Our platform, the bread and butter of our platform is traffic, right? So, and in a cloud provider like AWS, really in any environment, traffic, the most detailed information you can get about traffic comes from flow logs. It's called flow logs. And if you think about flow logs, like there's the idea of MELT, right? Metrics, events, logs, and traces. And I think traces get a lot of clout. But if you think about what a flow actually is, a flow is essentially like one span of a trace. That's what it is. So it's like information about what passed from point A to point B. And when I say information, this is a lot of data. It's very broad. There's a lot of like kind of unique data inside there to describe what's happening with that connection. And so what Kentig does is we take all of that broad data and we enrich it with context, and we do this automatically. So we grab information from the public internet, we grab information from cloud provider APIs, we grab custom information that you've set about your applications and businesses, or we'll grab automated things like tags so that we can give you context at what you're looking at, which if you've ever looked at a raw flow log, having that context enrichment is super nice because otherwise you kind of don't understand what you're looking at. But yeah, so what we do is we take all of that flow. We have a super efficient data engine that is able to enrich and crunch all of that really quickly. And then it can help you understand. So it's essentially like, it's actually not that sexy when I talk about it. So like really like what I can do is figure out what are my transit gateways or NAT gateways or Cloud WAN endpoints that are getting the most traffic, that have the most traffic that's going from the cloud to the outside, because that's where you get a lot of cost. Not necessarily, but that's one point where you get a lot of cost. And then you can sort them and then dig into that context that we enrich to understand like kind of why is that traffic being sent out? Who's sending it out? What's associated with that? What are the other data points that are associated with that resource? And with something like security, I can go back and I can see, okay, so in the last 30 days or the last 90 days, who hit, who was accessing these resources? Like what IPs were accessing these resources, or whatever kind of identifier you want to use. And then I can see, well, is everybody who is hitting this, like, is everyone authorized? Is all of this traffic the traffic that I want to be here? Or is there traffic that, is extraneous or, is suspicious? If the traffic is suspicious, our system will detect that for you automatically and let you know that there's an anomaly. But you can also go back and look through and say, hey, maybe these security rules that I have are a little loose, and maybe there are some things I can tighten up here. Or maybe there are some requests that have been being sent or connections that are denied, right? That are being blocked. So going back and understanding that to fine tune it to what you need is really useful. And from a cost perspective, looking at all of those different metered services and understanding what's actually going from point A to point B when those metered services are being used, and who's driving, which accounts and business units are driving those costs. That's the kind of information that you can get from our platform.
Yeah, no, that sounds, when you think about the complexity of what's going on, like you said, it's traffic flows, it's security patterns, it's, who's authorized, who's not, times a day, all those sort of things. Like having that context around it, helps in all sorts of ways, right? Whether it's just as simple as like, teams are looking at stuff. Are you tired? Can you remember what happened 2 days ago? All those sorts of things make a ton of sense.
Yeah.
Yeah, go ahead.
No, I mean, even just like I've talked to folks who, they deployed their workload to Kubernetes really fast to EKS, and then they find like, oh, there's actually a cost here when I'm transmitting this from availability zone to availability zone. Like, why did I design this way? And that can rack up. Yeah, Ethan's nodding. That can rack up huge costs, right? But those are the things that you don't know going in. And this is the thing. Even if you are like you have some serious systems engineering chops, you might not know until you don't really know until you see it, until you deploy it and you see it working. And then even to Ethan's point, as you see it scale, you're like, oh, what was like 0.003 cents a day before is now like $3,000 a month, right? So, yeah.
Right. Well, I mean, it's only 200 plus services across multiple clouds, so your ability to know how they all work and how much they cost is nearly impossible.
Right.
Yeah, absolutely. It's impossible to know every little nuance of the availability zones in this cloud provider and how does traffic moving in this one work, and it's just impossible to know everything.
Right, exactly. I'm curious. I know, again, from kind of digging into your background and the work you've been doing, you guys do a lot of work with AWS amongst other clouds. I'm curious, AWS obviously, and most of the cloud providers are like this. This isn't unique to AWS. They would sort of prefer you to say, look, we provide all the services you need from networking to storage, all the primitives, all the and at some point, there's a certain trend to say, well, that seems like an easy way to do things. It's all from the same place. They must have been designed together. They're all going to fall in the same bill. You've worked with the Kentic platform to sort of either augment or in some cases sort of replace things. Like, what was the thought process going on there, and where did how did you go about saying, hey, it might make sense to be using a product that integrates with the cloud but isn't necessarily native with the cloud? What was that sort of process involved?
Yeah. So you're definitely right. I mean, every cloud provider has some integrated solution for any problem you want to solve. They might not always be the best solution for your environment, and I think that's really important to highlight. In the case of flow logs, for example, with Amazon, you can send them to S3 or you can send them to CloudWatch. Once you send them to S3, if you want to use the native solution, now you're setting up an Athena database, you're doing data tables, and you're doing SQL queries. I'm not a database guy. I'm terrible at SQL. I can kind of bumble through it. I'm not good at it. So for me, if I'm doing a native solution, it's like, well, I can send it to CloudWatch logs then. It's the language for that's a little more accessible. It's easier to navigate, but it's still not great in my opinion. So the other part is cost. Amazon, when you send to CloudWatch logs, it's 50 cents a gig. So when you're doing, an application and you're just sending the CloudWatch logs and you're doing 50 meg a day, it's not bad. But flow logs can be really data intensive. In my career, I've seen some VPCs that send terabytes of flow data a day. So when you're starting to get into that range, you're looking at $1,500, $2,000 a day in CloudWatch logs. And if you see that on the bill, you go, where's this coming from? It's this weird vended log charge. What does this even map to? What's going on? And it's CloudWatch logs and it's VPC flow logs. So, in my opinion, one of the nice things about Kentic is you can sample that log ingestion. Flow logs are super nice. You might not necessarily need 100% of them, depending on what you're doing, because the nature of networking is so repetitive. You know, you have one server that's constantly calling another server. I don't necessarily need every single flow log.
And that's where sampling comes in. Yeah.
Absolutely. Yeah. With Amazon, you don't have that capability. You can sample when you query to make your query faster, but they're going to bill you for everything that they keep, and they're not going to let you turn down what they keep.
Yeah, so, and if you suck at SQL, then you may end up waiting for like 8 hours for a query to return, right? Has this happened to you?
Oh yeah, absolutely. And I think another good example of this is, let's say you go the Athena route, right? You're going with Amazon, you're using their service, you're doing Athena, and you're good at SQL. They're going to bill you to query your own data. It's $5 a terabyte to go through. So it's like, so you're billing me to log it, and you're billing me to use it.
Yeah. And again, it highlights a couple of things. It highlights the reality of being that 10x engineer. Like you said, you're not a SQL expert. It's not something that you necessarily have spent time on, which is not unusual. And then, like you said, it's should I pay to put the data in? Should I pay to take the data out? Should I pay to slice and dice it and all those sort of things? And it can potentially get to be very, very expensive. So yeah, I think it's one of those things that I also find a lot is people, their tendency is to go, well, I'll just use the native thing. And then, they stop exploring what else is possible. But there are a lot of folks, as we've sort of highlighted, who realize where there are specific domain specific problems and go build a better mousetrap, for lack of a better term.
And like Rosalind touched on, you get enrichment with Kentic as well. With Amazon, you get their flow fields, and that's it. And it's useful. It's good for a lot of stuff. But if you want geodata, you don't have that. Like there's so much that you just don't have, and you're locked into their ecosystem. So if you have on-prem data centers or you have other clouds, now you're managing multiple systems to look at this flow.
Right, and I would imagine you all have customers all around the world in all sorts of geographies. They're looking for flexibility. They may not all be in that exact same cloud in that exact same region and all those sort of things. I want to finish up with one last question, because I think it comes back to what we talked about at the beginning, which is as you're having to manage these complex environments, these SaaS environments, you've now got your business and your team managing that. You've got the cloud provider who, like Rosalind said, does a certain amount of things. Certain things are sort of commoditized. And then, Rosalind, you guys are augmenting that with a set of very unique specified services. I'm curious if somebody was sort of looking at this and said, where does one start? Where does your team sort of stop? Where do you expect Kentic to take over? Where do you expect the cloud to sort of take over? Like, what's the relationship there? Because I think, getting that right, having the right tools, understanding who does what really well, does kind of give you that superpower of being a 10x team. It's just doing it in that right way. So I'm curious, because you guys run global scale services, how do you go about thinking about that interaction?
We're thinking about like, where does Kentic, I think the interesting thing about your question to me is like, one of the things I had to wrap my head around working at Kentic is that what we do is observability. Like, that is what we do. So like, literally our platform, read only. Like, our platform is read only, which is a great thing for a lot of our customers who need that, who need that like level of kind of security essentially around the sensitive data that we are dealing with. But like, now with like some of the AI solutions that we are building specifically for network observability, like the holy grail is automated root cause analysis. And that's where we're headed. And that's what we're testing with customers now, in terms of being able to do that anomaly detection, or do that like, hey, this transit gateway is like, this is a ridiculous use of cost here. So like let's make some suggestions. So that's essentially maybe not automated, but it's decision support, like really good decision support. So I think like AI definitely blurs the lines of where observability, of that demarcation line between our provider and your infrastructure. But stepping back from that, I think ultimately like the power of observability, I'm going to say power twice. The power of observability is that knowledge is power. So like, if we can put the right knowledge, the right information, in the hands of people who know what to do with it, then we can make them way more efficient and allow them to do a lot more with their time and do the high value work, so that they don't have to be, digging around. In our case, it's like, dropping packets and things like, or I'm sorry, like dumping packets, right? Like, are they dumping packets to try to understand something, or are they quickly understanding contextualized flow data and knowing what to do with it and then moving on to the next task? So I think like our where observability really shines is from a people perspective, giving the people what they need. And that's where I get fascinated with how the teams and people working in software delivery have changed so much in the last 10 years. So I'm on this call with two folks with a network engineering background. I don't have a network engineering background, much more comfortable like with OS stuff and much more comfortable with like I love Red Hat, but I'm not necessarily like down there in the weeds with y'all. So, but someone like me, I could have been in a position of doing a job more like what Ethan is doing, right? Like I could be working in the reliability field now. So when I come to that job, do I actually understand am I the one who's dumping packets then and trying to understand what's going on? I can, if there's a database issue, then I can be really, I can get really in the weeds on something like that, or there's other things that I can dig into, but I don't necessarily have the expertise everywhere, like we were saying. And so what's interesting is that people working in I think part of what Kentic brings to the table, or what we're trying to bring to the table, is not everyone has a network engineering background, but that doesn't mean that they don't have the capacity to leverage kind of network engineering insights and intelligence if it's contextualized. And I think one of the things that you said earlier, Ethan, was Amazon is so good at telling you what it costs, but it's not good at telling you why. And I think what the why is maybe written in a different language for different people. So if you have a network engineering background, or networks make sense to you, or networks matter a lot in your environment, which is most of our customers, where the scale is just so huge that these network costs can go up and be costing thousands of dollars a day before you realize that there's a problem. When you're in that kind of environment, you need someone with a network engineering lens to look. So our role at this point is to broaden that lens a little bit and make it more accessible to folks, so that the person, Ethan, with the network engineering expertise doesn't always have to be the one answering the question. You can kind of broaden that out to other people and give other people access to the information. But I think that so I think that's where the understanding where the demarcation is not super simple.
Yeah, no, it makes sense.
I would definitely agree with what you're saying too, in that when you're dealing with traditional networking, let's say you have a server admin and they think that there's a network problem, and you're like, okay, well, I have this packet capture, go look through it and tell me what you find. They're not going to know. They might not necessarily know exactly what they're looking for, or really how to interpret the packets or stuff like that. And kind of the same with raw flow logs. It's very text heavy. It's kind of confusing. You have to be okay, this is the third variable in here, so that maps to this. So unless you're working in that stuff every day, it's really hard to kind of map that out. But I do think that the Kentic platform helps kind of democratize that data, because anyone can look at a graph and go, okay, well, at this time, this spiked, something happened. And then they could bring someone in and say, I have these two IPs, it's this time frame. This also matches up when we saw this issue. Yeah.
So it's kind of like putting in a little capsule, the guy who thinks of everything that's happening in your software as a graph theory problem. It's putting that into a little nugget so that other people can get that wisdom.
Right. Well, listen, I'm gonna wrap up there. We really appreciate both of your time, kind of helping us dig into and really kind of understand so many of the services that we use every single day, including the one that Ethan provides. I don't want to say we take them for granted, but we just kind of expect them to be there. And the amount of work and engineering and thought that goes in is not a simple task. It's not a task that's done by an individual person. And as we all know, once you start combining a lot of teams, a lot of complexity, you want to make sure you have the right things in place. So I was excited for you both to sort of educate us today on, what's the process, what are the complexities that you're dealing with, what are the dependencies, and kind of most importantly, what are some of the tools and skills that are needed to make this simpler? So Rosalind and Ethan, thank you both for the time today. Real quick, I'll leave it to you, Rosalind. If anybody wants to sort of reach out and learn about how you guys are helping companies like Ethan's, what's some of the best way to go about doing that?
Yeah, totally. I mean, definitely you should check out our website, kentic.com. And if you want to check out some stuff specifically about cloud, you can go to kentic.com/optimize cloud, which is sort of our page for helping folks with cloud optimization. And yeah, I think that's a good place to start.
Okay, excellent stuff. Well, listen, both of you, again, thank you again for the time today. Folks, I'm going to wrap it up. We want to thank both Rosalind and Ethan for their time. I want to thank you all for listening every week as you do. Thanks for telling a friend about the show, helping us grow the community, and again, sending in your questions, show@thecloudcast.net as you do each week. So with that, I want to thank both of them. We're going to wrap it up, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.